Okay, as in the last class we saw the simple parity check. Now in today's class we will see about the two-dimensional parity check. So in your two-dimensional parity check, as I told, the same conditions deals with this two-dimensional parity check also. So when it is of odd number of when the ones are in odd, you should give it as 1, and the ones are when it is even, you should give it as 0. So with this condition, what happens? Two-dimensional, ma'am, single dimension, you told we can have only this one condition, but for two-dimensional also you're just giving me the same condition. So it is okay, but with the same condition we are going on. But over here we will be having two checks. So one is your row parity check and another is your column parity check. So for example, I am just taking as 1 1 1 0 1 and 0 0 0 1 1. So over here again the same 5 digits I am taking, and then for example I am just splitting this binary numbers into row and columns. So I am giving you 1 1 0 1 and 0 0 0 1 1 and 1 1 1 1 1. So as you know, this is rows and this is column wise. So now we are just adding a redundancy data of bit. As I told you, the ones over here, if it is odd, you will be giving us 1. So here we are having 1 2 3 and 4. So if it is 4, it is even, so we will write it as 0. So let me just draw a line to differentiate it. And then we are having over here 2 number of ones, that is also even, so we are giving again a 0. And over here you are having 5 number of ones. So what happens? Automatically, if it is 5, it is, so we are giving as 1. So I have just taken it as 0 0 1 over here. So over here this row parity has over. So now the same way we have to take the column parity, which is your column towards downwards. So over here we are having only 2, that is of even, so that is 0. Over here also we are having 2, so we are writing 0 over here. Over here also we are having 2 numbers, we are writing 0 over here. So over here what happens? Even you are having 2 over here, so it is 0. And over here you are having 3 ones, so it is 1, and you are having only 1, so the answer is 1. So like the same way we did in the simple parity check, the same way we are doing it for your two-dimensional parity check, where this row parity and column parity are over. So while writing this, we should write with the same number of parity. So we will be taking this one first and this one second and this one as third. So now what happens? This number of this parity. So we have the original binary number is this. So this is your original binary number where we have converted into your two-dimensional parity check. So the first one will be your this number. So we will be writing as 1 1 1 0 1 0. So your next parity number is of 0 0 0 1 1 0. And next is your 1 1 1 1 1 and 1. So this is your 3 data which is we derived from your two-dimensional parity check. So now we will be writing it together as 1 1 1 0 1 and 0 and 0 0 0 1 1 0 and 1 1 1 1 1. So you are having 3 ones and 1. So this is your data from your two-dimensional parity check. So in the same way, I have just given over here only 3 binary numbers, whereas you can solve even with the number which is added with your another parity check. So your original data, now we can write this is your redundant data bits. Redundant data bits. And original data bits. Okay. So original data bits, I can write it above. So your original data bits will be of 1 1 1 0 1 and 0 0 0 1 1 and 1 1 1 1 1. So this is your original the data bits and your redundant data bits. So you will be having a problem like this. So we can by solving this error correction by using this simple parity and two-dimensional parity check, and this will be your final answer for this problem. So thank you.